focuses of class here, both the intra-AS and the inter-AS L3 VPN, because once you understand this, then we'll see that the next topic domain, which is going to be L2 VPN, is going to be much simpler to understand. Because in many cases, when we're looking at just a point-to-point pseudo-wire or a point-to-point Ethernet virtual circuit, as long as the underlying IGP network is working, as long as the underlying LDP network is working, then we have simply a couple commands on the provider edge routers in order to form our layer 2 tunnels. Now, just like in L3 VPN, though, this can get kind of complicated once we start to look at inter-AS interaction. And we'll see the logic of this is going to be very similar, that we could do carrier supporting carrier with L2 VPN. We could do unified or seamless MPLS with L2 VPN. And we'll essentially go through what are all the different variations that are relevant within our particular code versions. Now, one of the big limitations we'll see of this, though, is that the specific software version that we are using for iOS XR, which is the iOS XR-V virtual machine, it does not support the data plane for layer 2 VPN. Okay, the same is going to be true of the actual exam. There's, as far as I know, there's not a separate version that does support the data plane for L2 VPN. So for some of these configurations, we'll just be looking at the config of them and then the building of the control plane, but we won't actually be able to send traffic through in order to test the data plane. But we'll see the regular iOS versions, the CSR 1000Vs, they do support data plane for L2 VPN, but there are some key functional differences in terms of what does regular iOS support versus iOS XR. Now, beyond this, once we form the core routing, then we do the intra-AS, inter-AS, L2 VPN, and L3 VPN. Then we're into our services. So services will be multicast over L3 VPN. So how does the multicast distribution tree work? How does the new MLDP work as a multicast over multicast type solution for tunneling? We'll also look at MPLS traffic engineering. We'll look at both intra-AS, intra-area, and inter-area, inter-domain traffic engineering, and then talk about some of the advanced features of this, like MPLS traffic engineering fast reroute, link and node protection, and some of the other more advanced options with TE. And then beyond that, our other services are going to be QoS for MPLS, and then also MPLS services and security. In terms of things like how do we protect the LDP control plane, how do we protect the IGB, BGB control plane, and then what are some of the additional MPLS-enabled services like MPLS-enabled NetFlow, network address translation, etc. So next, let's talk about the specifics of the SPv4 blueprint. And there's two portions to this, just like any other track. We have the written exam and we have the lab exam blueprint. And you can see the direct links to these to the PDFs if you follow those in the PDF version of the slides. But let me go ahead and open this up from the manual navigation path. So what you want to do is go to cisco.com/go/CCIE. And then from here, we're going to go to CCIE Service Provider. And then step 1 is going to be the written exam information. And then step 2 is the lab exam. So then under here, under the written exam, we want to go to the review the exam topics. And then the exam topics in PDF. Okay, same is going to be true for the lab exam. So under lab exam info, go to lab exam topics. And this one you have to log in for. And then let me go back one page. So this is under lab topics. And then the lab in PDF format. Okay, also if we go back one step here to where it shows the overall list of the lab topics versus the written topics, you'll see that these overall topic areas are very similar between the two of them. But the difference is that in terms of the written exam, there's another section here, the first one, which is service provider architecture and evolution. The rest of them core routing through services, operations, and management. In terms of the lab, only the last 5 sections, or basically the first section of the written exam, is not included within the scope of the lab. Otherwise, most of the stuff is fairly on a one-to-one basis. So in terms of the written, if we look at the first section, this is mainly platform overviews, like what's the difference between iOS XR and iOS XE? What's the difference between the different components of MPLS in terms of the provider edge routers versus the provider routers, the customer edge routers? I would say that you don't necessarily need to prepare for the written exam separately, because we are going to be discussing all these topics from a theory point of view before we get into the actual implementation. Now, we will talk about specific resources that you want to look at outside of this class in terms of regular printed books or online books, as well as documentation resources, Cisco Live presentations and videos. And the combination of all those together are going to be enough to prepare for both the written exam and the lab exam at the same time. So at least in my personal opinion, when I'm preparing for a CSI track, I don't prepare for the written exam separately. I just do both of them at the same time, and then when I'm getting towards my later stages of preparation, then I'll simply go take the written exam, and once that's done, then schedule a lab exam not too far afterwards. So in other words, I wouldn't shoot to take the written now and then plan on taking the lab exam 9 months or a year from now. I would wait until a little bit later in your preparation, once you're more comfortable of the topics overall, not only from a theory point of view, but also from an implementation point of view. So then when we look at things like describe, implement, and troubleshoot ISIS, if you already know the theory and you've already been doing this live on the CLI, then hopefully the written exam is going to be fairly straightforward when you ultimately get to it. Okay, so as I mentioned, there's going to be 6 topic domains overall, and all of them are going to cover both IP version 4 and IP version 6. So as I mentioned, we're going to be looking at both iOS platforms, iOS XE as well as iOS XR, and we'll also be looking at, for each of these subtopic domains, both IPv4 functionality and IPv6. So this means for IGP routing in OSPF v3, we're going to be routing both IPv4 and v6, and then likewise in IS to IS. But otherwise, that first topic domain is only in the written exam, the SP architecture and evolution. And you'll see the other resources that I'm recommending will pretty much cover this stuff regardless. Okay, there may be some minor things that aren't listed on here that you will need to read through some of the specific documentation for, like the NV functionality of iOS XR, which is like a chassis virtualization type feature, and then as well as the secure domain routers, which are kind of like a virtual context of iOS XR, but it has a more physical aspect that is related to it. Okay, so these ones we'll talk about a little bit more later when we go over the general overview of iOS XR. Okay, then we get into our core routing topics. Now you'll see specifically in the blueprint, there's a lot of topics that they continue to reference over and over and over, like IGP and BGP is referenced multiple times, regular MPLS is referenced multiple times. But if you look at the way that they're essentially describing it, is typically the way that you would want to build the network. So when we look at the specific lab exam blueprint, and it says the first thing we have is core routing. So they're basically saying you need to establish IGB connectivity before you can establish BGP connectivity. And BGP connectivity is going to be needed before we can actually do any MPLS label switching. Okay, likewise in the core of the network, this is also where MPLS traffic engineering is going to exist. In our particular case, we're going to look at this after the L2, L3 VPNs, and then see what are the interactions with both of them at the same time when we're running TE on its own just for the core label switching, and then when we're running TE in conjunction with L2 and L3 VPN, and what are some of the interactions, what are some of the caveats that we need to know about. Okay, once we get past core routing, then we have the service provider services. So this is where the main focus of the class is going to be, our particular class, which is going to be the L2 and the L3 VPNs. Now we'll see, and we'll talk about this in a couple minutes here, what are some of the specific changes between version 3 and version 4 of the SP Blueprint. And this topic domain is where most of the major changes exist. In terms of new features for MPLS Layer 2 VPN, like HVPLS as well as PBB EVPN, and we'll talk about later what specifically those mean. But this is where the most changes have occurred in the blueprint. Okay, also in terms of overlay VPNs, they also added multi-point GRE, which is going to be for a DMVPN, and then also for Lisp tunneling, which is going to be for mobility as well as like IPv6, IPv4 tunneling. And then L2TPv3, this was on the previous blueprint as well. This is essentially just a point-to-point layer 2 VPN. So it's a layer 2 IPVPN as opposed to an MPLS layer 2 VPN. It basically means that you could run this like over the internet without requiring an MPLS provider in the middle. Okay, then we have access and aggregation. This is where we have our PE to CE routing. So we'll see most of this is going to relate to MPLS layer 3 VPNs. Because when we're doing an L2 VPN, the customer's routing infrastructure is transparent to the service provider. So L2 VPN is like legacy frame relay or legacy ATM, legacy T1, T3 connectivity, where you have a routing peering to your own customer site. You don't have a routing peering between the provider and the customer. Okay, we'll also see it in terms of QoS and multicast. This is where we're going to be looking at multicast over the MPLS service provider. So this is going to be, which is where? This one, which is going to be MLDP, and then also the multicast distribution tree. So basically tunneling multicast over the L3 VPN provider. Okay, then last but not least, we have high availability, fast convergence, and then SP security and operations. Now, HA and convergence, we'll be talking about this in the individual topic domains as we go through them. Like today in terms of core routing, we'll talk a little bit about how does IGP do fast reroute in terms of OSPF LFA and ISIS likewise. And then we'll revisit this later when we talk about MPLS traffic engineering and see how fast reroute link and node protection works a little bit differently than the IP fast reroute counterparts, and then also how BGP does prefix independent convergence, how LDPs does session protection. So these particular topics, there's not going to be a separate section that we'll dedicate to them because they'll kind of be sprinkled in throughout the individual topic domains as we go through them. Okay, but the last section, security, operations, and management, we will have a separate section for this dedicated that talks about things like how do we secure the control plane versus securing the data plane, or how do we do net flow, how do we do SNMP monitoring of an MPLS core-based network. Welcome everybody to INE's CCI Service Provider V4 Advanced Technologies class. My name is Brian McGann and I'm going to be your instructor for these particular sessions. For those of you that haven't attended a class with me before or seen any of my previous videos, I am a CCI in service provider as well as routing and switching, security, data center, as well as a Cisco certified design expert. You can see my contact information there. So during class or after class, if you have questions, feel free to shoot me an email. It's bmcgann@ine.com. And additionally, my Twitter there is @BrianMcGann and LinkedIn.com/BMcGann. Now, in terms of today's agenda, first thing we're going to be going through is just an overall overview of the class in terms of what are the topics that are going to be covered, what is the format that they're going to be covered in. Then we'll talk about the new Service Provider version 4 blueprint and talk about what changed between version 3 and version 4. Also talk about the specific hardware topology, what am I going to be using during class, what can you use after class, and then how does that compare with the actual hardware specification used in the actual lab exam. And then we'll get into our technical topics. So specifically for today, technical topics, we should be able to get to at least our iOS XR introduction, and then also into some core routing topics in terms of OSPF and ISIS routing. So next then, for those of you that haven't attended this class before or in other tracks, what is the Advanced Technologies class? And essentially what this class is in order for us to learn a structured approach for the configuration, the verification, and the troubleshooting of the technologies that are within the scope of Service Provider version 4. So most of the class we'll see is going to be me doing live hands-on examples. There are going to be some technology explanations. There are going to be some slides that I'm going through, but the main focus really is going to be hands-on live on the equipment. Now, related to this, as you guys will likely see as I'm going through these examples, this is not pre-scripted.
In this video, you and I get to set up a Cisco router to act as a certificate authority for issuing digital certificates. We're also going to set up a second router acting as a client to both authenticate and enroll with that CA server. One key element of using RSA signatures for authentication of either IKE version 1 or IKE version 2 is to make sure we have digital certificates installed on the devices that want to use them. To do that, we're going to need some kind of a common certificate authority who can issue certificates. And in this micronugget, you and I are going to create a certificate authority out of an iOS router and then train an iOS client to use that certificate authority. We're going to configure R5 to act as our certificate authority server. So to do that, let's first of all start off and enable HTTP server on R5. SCEP, the Simple Certificate Enrollment Protocol, uses HTTP for the authentication and enrollment of its clients. Next, we'll put a minimum configuration in for the server. The syntax is crypto PKI server, and the name we want to call it. The issuer name is going to be CA in the organization called cbtnuggets.com. We'll tell it to go ahead and automatically grant requests for certificates that come in, and then we'll bring it up with a no shutdown command. It's asking for a password. It's asking me to confirm the password, and that's going to protect the private key from the private public key pair that has just been generated for its own digital certificate. To verify, we'd use the command show crypto PKI server to see the details of this CA server. So here's the grant of auto. Here's the issuer name, which is ourself. So now this CA server is enabled and active. Before we make R1 a certificate authority client, let's make sure we have basic connectivity between R1 and the loopback address on R5. And we do. That's a great start. Next, let's go into configuration mode and use the command crypto key generate RSA. And I'm going to specify a modulus of 2048. And I'm also going to create a label to give to this RSA public-private key pair that we're creating. And the label I'm going to give it is r1.cbtnuggets.com. It could be Bubba or John or whatever you want to refer to this specific key pair. Now that R1 has the public-private key pair, let's go ahead and tell R1 about this beautiful certificate authority. The syntax for that is crypto PKI trust point, and then we're just going to use a locally significant name. In this case, we'll call it trusted-CA. Now R1 may be wondering,